Hello, this is Charlene. We're going to convert this equation to vertex form and also list the quadratic characteristics. So the first thing we want to do, though, is remember and remind ourselves that this is the standard form of a quadratic. And there are things that we can tell about it just by looking at this version of our quadratic. So the first thing, of course, is that we can say this is in the function family, the quadratic function family. So that is a given. And how do we know that for sure? Well, of course, this video is called quadratic characteristics, but it's actually because we know that the highest power on our variable x is a 2. Anything that the highest power is a 2, that means it is a quadratic. So we can confirm that because of the x squared. Okay, so the parent function, we need to remind ourselves that the parent function for a quadratic is the parabola that is centered at 0, 0 at the origin in the middle of a coordinate grid. So that would be y is equal to x squared. That is the parent function. That's before it starts moving all over the place. When it starts moving to different places, that's where we get the 2x's and the negative 48s. That means things are moving around and it is no longer centered at the origin. Okay, so we also can think about, is it a minimum or a maximum? Well, this is a happy parabola because the x squared term has an invisible plus sign in front of it. It's positive, it's plus, it's happy, it's positive. That means it's going to graph like a happy parabola. It looks like a big old smile. That means its vertex is going to be here at the bottom. Well, that vertex at the bottom is going to provide us with a minimum. So we are going to have a minimum down here at the bottom of our parabola. So it's a minimum. We also can look at, we cannot tell the axis of symmetry just yet. So let's skip down here to the y-intercept. The y-intercept will always be this third number. Let me erase some of this stuff right here. There we go. Okay, so yeah, this third number, negative 48, whatever that constant is at the end of our standard form quadratic will be our y-intercept, but the y-intercept is a point, so we need to always write it as 0, negative 48. 0, negative 48. Okay, and we cannot yet tell about the vertex, so we'll skip that one. The domain. Okay, so the domain for all parabolas, if we've got a happy parabola or if we've got an unhappy parabola, either way, it doesn't make any difference because it's going to go on forever that way, it's going to go on forever that way, it's going to go on forever that way, it's going to go on forever that way. And what we know about things that go on forever and ever and to the left is going to be the negative infinity. So it's going to go on forever and ever and ever in a negative infinity direction. It's going to go on forever and ever to the right in a positive infinity direction. And we write that in interval notation like that. But what includes negative infinity to, or what does negative infinity to infinity include? Does it leave any numbers out? No, it does not. So we can also, if we want to, just use the shortcut and do all real numbers. We can use this little symbol for all real numbers and write it either way. Interval notation. Oh, and I wrote that in the wrong place. Let's see, let's move that down. Oops, that's not the vertex, that is the domain. Okay, so the range, we're going to wait. So these three things right here, the axis of symmetry, the vertex, and the range, we are going to wait until after we convert it to the vertex form and or after we graphed it. Okay, so let's go ahead and work on this process of converting this to vertex form. So how do we convert this equation to vertex form? Well, we are going to use a magic bullet. The magic bullet is essential to this process, and that's what this is right here, magic bullet. Now, we do not have any leading coefficients over here. We only have an invisible 1. So we're ready to just jump right in and use our magic bullet because we have no number over here to deal with to possibly have to make changes to it. We can jump right in. So the B number right there is going to be this number right here. The 2 will be the B. And you see right here, I have actually already plugged that in. 2 over 2, it's b over 2 squared, and that's equal to the 2 over 2 because our 2 is the b squared. And of course, that is going to be equal to 2 over 2 is 1, and 1 squared is just 1. So that means that my magic bullet is going to be equal to 1. Okay, so now that we've identified what our magic bullet is, we are going to do this. We are going to set it up this way. Now, let me erase this stuff for just a second so you can clearly see this. Okay, so this negative 48, the magic bullet is going to replace the negative 48. The negative 48 is just really not convenient. It's not working for us, so we're literally adding 48 to both sides. Add the 48 to both sides to get it out of our way, because we are now going to put in its place the magic bullet. But order of operations and algebra tells us that if we add a number or magic bullet to one side of the equal sign, we also have to add it to the other side of the equal sign. So this is how it's going to be set up. It's going to be x squared plus the 2x plus the magic bullet is equal to the 48 that I've moved to the other side plus the magic bullet. Okay, so at that point, let's go ahead and plug in the magic bullet. So when we plug in the magic bullet, 1 is going to replace where I wrote MB. So the magic bullet is 1, and I have put in a 1 right here and a 1 right here where I said the magic bullet needed to go. Okay, so let's just keep simplifying it just a little bit and go ahead and add that 48 and that 1 together. So there we go. We have now got x squared plus 2x plus 1 is equal to 49. Let me make all this stuff a little bit smaller so that I can have more space. That's not working. Let's try that again. See if it'll let me do that. That would be helpful. Yes, good for me. Okay, so at this point, I need to recognize that this right here is a perfect square trinomial. So now that I've added the magic bullet, when I put that magic bullet in there, that now gives me a perfect square trinomial because I put the magic bullet in it. And what is special about the fact that this is a perfect square trinomial is that it is very simple to factor this piece of it. So this piece is going to factor easily, and it is going to be this, oops, where'd it go? This right here. This is the factorization of the perfect square trinomial part. Okay, but then we also have this equals 49 over here, so let's go ahead and grab that and add the 49. But I just wanted to point out that x plus 1 squared is the factorization. Now, how do we arrive at that? We actually arrive at that by taking the square root of the 2 of the x squared, square root of the x squared, which gives us the x, and then we put this plus sign, the plus sign's right there, and then we take the square root of the 1, which is 1, and then we square it. So that's where we get that. The x comes from right there, there's our plus sign, and there's our 1. So that's where we get all the pieces. Okay, so at this point, it essentially is almost in vertex form, but we're going to go ahead and move that 49 to the other side. So when we do that, we're going to end up with let's see here, we're going to end up with 49 on the other side of the equal sign. So basically what I just did is I subtracted the 49 from both sides again in order to move it back over with the squared expression. Okay, so we are almost there to vertex form. This really is vertex form, but we've got a formal way to write it, and I think it's really important that we kind of understand how to formally write our vertex form. So this is the way it's going to look. We're going to put an f of x in it. We're going to say, instead of saying x plus 1 in parentheses squared minus 49 is equal to 0, my formal writing of the vertex form is going to be f of x is equal to x plus 1 in parentheses squared minus 49. So this will be my formal vertex form. Vertex form right there. Okay, and the reason why we call it the vertex form is because it is incredibly simple to identify our vertex. So the vertex of our quadratic, of our parabola, is going to be -1, -49. That is the vertex. And those two numbers, there, it comes from this, +1. It's going to be the opposite sign of this one. That gives us the -1. And then I've got a -49 here, and that stays the same sign. So -1, -49. But it comes from +1, -49. So +1, -49 in my vertex form gives me the vertex of -1, -49. Alrighty then. So over here on the side, we needed to go back and look at the vertex. So we now know what the vertex is. There is my vertex. So I can go ahead and list that over here as information that I now know about my quadratic. It is -49, -40, oh, -1, -1, -49. That is my vertex. Okay, so now that I know my vertex, I actually now know my axis of symmetry, because my axis of symmetry will go right through the center of my vertex, and it'll be identified by a line that goes through the x value of my vertex. So my axis of symmetry will be based on this x value. My axis of symmetry is a line, and so therefore it has the line has the equation x is equal to -1. But like I said, you just need to understand that this -1 helps me identify the axis of symmetry. Okay, and range. Let's see. Let's go ahead and start graphing it. That's what we need to do. So we need to understand that we only need 2 points to draw a rough sketch of our parabola. Okay, and those 2 points are the vertex and the y-intercept. So if I do that, if I plot those 2 points, let's go make that. Okay, so here we go. So if you look at my 2 points that I've already plotted here, this one right here, this is my y-intercept. Y-intercept. And this right here, this point right here, that's my vertex. My vertex. So I said that I only needed 2 points. Well, those 2 points are the y-intercept and the vertex. Once I plot those 2 points, then all I have to do is realize that the vertex is going to be either at the vertex is either going to be at the tippy top or the tippy bottom. So if my y-intercept is up here, I have to start from the vertex and go toward the y-intercept. So I would go start at the vertex and go toward my y-intercept. And of course, I just match it on the other side. Does that make sense? Okay, so hopefully that helps you know how to draw a rough sketch of a parabola. Okay, so what else do we need here? Range. We need to talk about the range. So the range has to do with the y values. Let's find a different color here. Range. Okay, so the range has to do with the y values. Has to do with the y values. And it basically is like, where does my graph start at the bottom? Where does it start at the bottom? And where does it go to? Where does it go to at the top? So the thing is, though, is that it is starting at this bottom, that minimum. That's where it's starting. It's starting at the bottom at the minimum. So that means it's starting at that -49. And where's it going to? Well, it's going on and on and on forever. And where is forever? Forever is in infinity. So that means that my range is going to start at the bottom at my -49, and it is going to go up and up forever and ever and ever toward positive infinity. So that means I can go up here in my formal place to put the range, and I'm going to say that it starts at the bottom, and it does touch it. That bottom vertex does touch -49. So we put a hard box here. This means it's actually equal to the negative 49 there at the bottom of our parabola. So it's negative 49, and it goes up to positive infinity forever and ever. Okay, so let's keep moving forward. What do we need next? Okay, so we need to look at the end behavior. The end behavior is what is my graph doing at the ends? Well, here is one end of it, and here's another end of it. And this says as x goes to positive infinity. Well, that means it's going, positive infinity means it's going to the right. So as all my x's are going that way, what is my graph doing? Well, my graph is going this way. Was that going toward positive numbers or negative numbers? Well, all these y numbers up here, these y values, will all be positive numbers. So it's going up here to the positive infinity. And again, on the other side, as my x is approaching negative infinity, which negative infinity, negative x numbers are going that direction. So it's like, well, as all my x's are going that way, what is my graph doing on this side? Well, it's still going up toward positive y numbers. So positive y numbers, and it's going on forever. So positive y numbers. So both of these are going to be going toward positive y numbers. The graph is going up toward positive numbers. So on the right-hand side, it's going toward positive infinity, and on the left-hand side, it's also going up toward positive infinity. Okay, and now let's talk about the increasing intervals. The increasing intervals, this always has to be considered from left to right, from left to right, from left to right. What is my graph doing from left to right? Well, if I'm looking at it just from left to right, well, what's it doing over here? It's going down. So that's decreasing on that side. It's decreasing on that side because it's going down. And then here at the vertex, it shifts gears and it starts going up. So it's decreasing from out here, and where is this going? It's going to infinity. So it starts at infinity and it keeps going down, 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 and then it gets to that vertex. And then it stops, it shifts gears, and then it starts going up, 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 up to positive infinity over here. And this is coming from negative infinity, I should say. That was negative infinity down to the vertex, and then it shifts gears, and then it goes up, 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 increasing toward positive infinity. So my increasing, okay, so I need to make sure and distinguish between this. So my increasing is from the vertex at -1 to positive infinity. Okay, hopefully that makes sense. It's going to increase starting at the vertex, the x value of the vertex. So it's going to start at -1 and it's going to go up to positive infinity. I should change that to red. All of my answers are officially in red, right? Okay, so it's going to start at the -1 and it's going to go to positive infinity. Let's talk about that again. Increasing starts here at the vertex and then goes up to positive infinity. So it starts at that -1 and then it goes up to positive infinity. The decreasing's over here, decreasing. So it started decreasing way over here in negative infinity, and it went down, 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 decreasing down, and it shifted gears at that -1, that vertex number. So that means it is starting to go down way over in negative infinity, and then it goes down to that -1 in the vertex, and then it shifts gears. Okay, so hopefully, oh, we got transformations. Let's do this. This is so much fun. Okay, so we got the transformations. Well, the transformations can all be identified from the vertex form, and here is our vertex form that we found earlier in the video up here. Yeah, right there was my, there's my vertex form right there. Right there, vertex form. Okay, so I went ahead and have it written down here. From this, we can identify all the transformations. Okay, so the transformation left to right has to do with this number right here. If it says +1, it actually means it's not going in a positive direction, it's actually going in a negative direction. So a negative direction would be that way. So that is left. So it's going to be left 1 unit. That's what +1 means, left 1 unit. Okay, and then we also have shifting up or down? Well, the number that tells me whether it's shifting up or down is this number, negative 49. Well, this is going to be the same sign. The shift left or right will be the opposite direction of the sign. This will be the same sign. If this is negative direction, then it actually is going a down negative direction. So it is going to be down 49 units. 49 units. Okay? And then the vertical stretch has to do with, is there a number here in front? Well, there's only the invisible 1. If there's only the invisible 1, then that means that there are no stretches or compressions. There are none. And that's because we have an invisible 1 here in front of our parentheses. Okay, and also the reflection also has to do with what's in front of here. Are there any negative signs here in front? No, there are no negative signs. A negative sign means that it would have flipped upside down. That would be a negative sign, but it did not. There are no reflections because there are no negative signs in front. No negative signs in front of my function. Okay, so I think we are actually at the end of all of our characteristics that we needed to talk about with respect to our quadratic. Hopefully this helps you understand how to think about it, how to go through the process, and you can see how much information you can arrive by converting it to that vertex form right there. Okay, have a great day. Click on the like button, click on the subscribe button, and we'll see you again later.